Okay, what this video is about, folks, is finding zeros of polynomial functions. Now, why is this true? Because finding zeros is really the method of solving polynomial functions for a given phenomena or application. Now, so we want to find the zeros, which means we're trying to find the values of x that cause the function to be zero. Best way to do that is to just set the expression equal to zero. Now we could use some of the skills that we acquired before. We could factor a 2 out, and we can factor an x squared out. If I do that, I have x squared minus 1. Okay? Now we know how to factor. So that's 2x squared, and then this is x plus 1 and x minus 1. Okay? So the question is, what are the zeros? Well, what value of x causes this factor to be 0? 1. This one, -1, and this one, 0. So there are 3 zeros to that particular function. Okay? Although we had a power of 4, we ended up with 3 zeros. All right, let's try this function. Now remember, we want to set the function equal to 0. Okay? You know, it helps while you're writing to think about what you're doing. Now, let's factor an x out. If I factor an x out, I have 2x squared minus x minus 3 is equal to 0. Okay. Gee, I wonder if that factors. What's 2 times 3? That's 6. So the factors of 6, that would subtract and give me a 1. 3 and 2. All right, so let's see if we could break that down. Well, you know that's a 2x squared, so 2x and x. Now, if we put the 3 over here, that would be 6, so we don't want that. Put the 3 here. Put the 1 here. All right, now remember, this is going to be 3. That's going to be 2. The higher number has that sign, so minus and plus. All right, so my question is, what are the zeros of this function? Okay, the maximum would be 3, right? That makes sense? So this is -1. This is 0, and that's going to be 3 halves, or 1.5. Again, we're finding the zeros of the function. How about this function? Now, maybe you don't recognize it as a perfect square trinomial, but could I rewrite that? Let's just say x squared minus 6x plus 9 is equal to 0. Half of that coefficient squared does give me that, so it's the same thing as x minus 3 squared is equal to 0. Now, just for the sake of argument, and this is why we like math. It's not like we're changing the rules all of the time. Of course, the rules don't change, and that ought to, ask us, why don't the rules change? Now this root's 3, and this 0's 3. Now the question is, what is the 0 of this function? Well, the 0 is 3. How many times is it showing up? It's showing up twice. What would be another way of saying that? We'll say the 0 is 3 with a multiplicity of 2. Can we understand that graphically? Sure. We know what this is. This is a quadratic, and it's to the right 3. And remember, it's curved up. Now the question is this: the 0 is 3, but the function does not cross the x-axis, it touches the x-axis. So this reminds us, whenever you have an even power, the function's going to turn. It's not going through the 0, it's turning at the 0. Maybe that'll help you out. Okay, now here's a question. Could you tell me the zeros, and could you come up with a general ballpark figure of the graph? Well, good question. Okay. Well, let's find the zeros. So here we go. X minus 2 cubed times x plus 5 to the fourth. We want to set that equal to 0. Well, now we know this 0 is 2 with a multiplicity of 3, which means it crosses the x-axis. This has a 0 of negative 5 with a multiplicity of 4, which means it turns, okay, at the 0. Another thing we can know is if I multiplied this all out, which we're not going to take time for, that first term would be x cubed. And that first term would be x to the fourth. Now, what is x cubed, x to the fourth? That is x to the seventh. Okay? Is that odd or even? It's odd. Is it plus or minus? It's plus. So that means that the function is going to have generally that shape to it. Now, what about the y-intercept? Can you tell me where the y-intercept is? Well, let's do this. Negative 2 cubed would be negative 8. And 5 to the fourth. Well, let's see, that's 25 times 25, which is 625. Now, 625 times a negative 8 is a very large negative value. I don't think we're going to be able to, make that work on a graphing calculator. But it's way down here. So now, the next question is, could we, if we wanted to, try to graph the function? Good question. All right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, I'm going to leave off the values for the y, or the tick marks for the y. I have the x pretty much taken care of. Now, what do we know? We know that there's a 0 at 2. And we know that there's a 0 at negative 5. We also know the general shape starts here. It falls to the left. So falls to the left means the function is going to have that general shape to it. And it rises to the right. Rises to the right. Okay? So we get that. All right. We also know that the y-intercept is way down here somewhere. Okay? I'm just going to put a dot right here. Okay? All right. Now, there's some other information we know. We know that it goes across at the 2. So this looks good. Goes across at the 2. Okay, so I could get that. So it crosses, kind of scoots a little bit here. So I could do that. And it turns at the negative 5. Turns at the negative 5. So my question is could you draw a graph that includes all of those aspects to it? Okay, and there you go right there. Now you could try to put that on your graphing calculator and graph it, and that's a possibility. But I hope that helps you get an understanding of how to put all of these things together. And you don't have to have all the exact values here, in order to get a gist of the function. But understanding the function really, really will help you. And I hope that does help you with this particular part of the lesson.